logarithmic one. Maybe this will kind of help you guys out a little bit. Maybe make a little bit more sense. Huh? Yeah, I mean, this is just kind of, that's a lot. It's a lot going on, right? So let's look at this one. Same process. Let's just, if you guys can follow the process, that's what the main important thing. First thing, you don't need to write this, but you guys should know this is the parent function of ln of x, right? The logarithmic function. It's on the sheet of paper, ln of x. So then what's the transformations? Now notice I have a b here, right? So I need to make sure I include that. So let's do all a, b, c, and d. So the transformations of ln would look like this. Okay, that was your third form that I provide you guys on your notes. That was the third equation that I wanted you guys to have on your notes. Now, I technically made a mistake on your notes last time. I was showing you guys how when you factor that b, you have to factor that out. So I showed that like a c over b. But in reality, it's really just a new c. Okay, so if I could take back those notes, I would. But either way, if you guys can just start with this. Now let's identify. Do we have an a? Well, yeah, a is 1. So, but does that apply to any transformations? No. So we don't really need to worry about the a. Here in this case, though, and do we have a c? Are we adding or subtracting anything inside the function? No. So we don't really need to worry about a c, right? But we can see here, my b is equal to -2, and my d is equal to -1. So then we go to our notes and we say, OK, so if b is negative, what does that do to my graph? If b is less than 1 or less than 0, that means it is a reflection about the y-axis, right, horizontal. OK. The absolute value of b, if that's greater than 1, does anybody remember that? It's all in your notes. Horizontal compression.
So absolute value, -2, absolute value 2, and that's where you decide the other.
Yeah.
Okay.
And then we have the d. So d, if d is negative, that means it's shifting the graph down 1 unit. So we could say shift down 1 unit.
I have a question.
Yep.
So do you do the third one, which is ln? Do you do that kind of formation? There's ln in there.
Do you do what with Ellen?
There's ln there. Do you have to write in that transformation?
You don't have to. No, you don't have to. I was just doing it so you guys could see where the A, B, C, and D come from. You don't need to write this. You don't need to write any of this really right there. I'm just showing it so you guys can kind of make the connections.
Okay.
All right. So the next thing is let's graph the parent function. What the heck does ln of x look like? Well, ln of x looks something like that. That's the parent function. That's what I told you guys. Hey, you need to write this down and make sure you guys have it. And also remember there is a vertical asymptote going on right here. So now, if I reflect about the y-axis, you're taking this graph, flipping it around the y-axis. You're going to have a horizontal compression of 2, so it's going to be kind of like smushed a little bit. And then you're going to shift it down 1. So really the one point that you have for this graph is 1, 0. So if you reflect it over the y-axis, it's now at -1, 0. And if you shift it down 1, it's going to be shifted down to -1, -1. So the graph is probably going to look something like this. Again, I'm not worried for you guys getting the correct graph with the stretch and compression, but you should at least see that, OK, that's how the graph is being reflected and being shifted down.
So if you're reflected and then you shift down.
Yes, you apply the order of operations. You always apply the multiplication to the operation first, and then there. So that is our function f of x. So now let's look at the domain. Well, the domain got affected, right? Because there was a reflection, right? Remember the domain is only affected by horizontal shifts. Even though we weren't shifting it left to right, the domain got reflected, so that affected our domain. So in this case, it's -infinity to 0. 0 is not included, though, because it's an asymptote. And then our range. Now here's the thing. We talked about how the range could affect the graph, right? But we were talking about the square root function, and both the domain and the ranges were restricted. In this case, my range is not restricted, guys. This continues and this increases to -infinity. This graph, sorry, goes from -infinity to +infinity. So if you have a graph that extends to infinity, -infinity, both directions, does it matter how you shift it up or down or reflect it?
No.
No, the range is going to be unchanged. So that's what's kind of nice. If you guys look at your parent graphs, if you guys remember doing the domain and range, majority of them all have a domain and range that, or at least one domain or range that's unrestricted. So therefore, it doesn't matter what transformations you apply, it's never going to really change.
So the range of infinity and infinity?
So the range is from negative infinity to infinity.